This video is designed to show you how you can use a spreadsheet to implement Euler's method for solving the problems in section 3.1 of our book. I'm assuming that you don't have much experience with spreadsheets as I make this video, and so I'm going to try and take it from the basics. So I'm assuming that you found this link, and so you're looking at a spreadsheet like I am. In order to use this, the first thing I'm going to do, and I want you to do, is make a copy, because I can't edit the original spreadsheet, but I can edit a copy. And when I do, it says it's going to call it copy of Euler's method for example 3 from section 3.1. That's fine by me. You can call it whatever you want. You can change the name if you like. So we're going to focus on this. There are two tabs at the bottom. We're going to focus on the one that says space to do work. Later, you might look at this example 3 with a graph, which already mirrors what's in example 3 of your book. Speaking of your book, let me pull that up for a second. So here's example 3 from the book. And I want to point out that the problem says to use Euler's method with step sizes 0.1, 0.05, and 0.025 to find approximate values of the solution of this initial value problem. And you'll notice that if you solve for y prime, you would get negative 2y times x cubed e to the negative 2x. And so I wrote that here. You'll notice the caret symbol, which is on my keyboard, it's shift 6. That's what you use for exponents. And there's also a function exp with parentheses, and that stands for e to the whatever's in parentheses. In this case, it's negative 2x, and you'll notice that I need an asterisk for a multiplication sign, and that's shift 8 on my keyboard. But this is only a label. This isn't really actually doing anything, and I want to explain what I mean by doing something here, and I think it will help if I zoom in a little bit. So I'm going to go ahead and do that so that you can see what I think is the most important part of the spreadsheet, which is this little white ribbon here where it says FX. And the way this works is spreadsheets are filled with what are called cells, and cells have coordinates. So we are in cell A1, and it says f of xy equals. If I move over and click on cell B1, that's what I was just talking about, negative 2 times y plus x cubed times e to the negative 2x. If I click on C1, it'll tell me this is only a label. So basically, I'm going to click on A2, and there's nothing here. So I'm going to scroll down to cell A4, and you see there's a 0, and B4 is 1. And you may want to change the initial value. That's why I have these in a different color. You'll notice that H, the step size, is 0.1. That's the first one we need, but we're going to change that later too. So now is where you can start understanding the power of the spreadsheet. I'm going to click down here, and you'll notice that this 0 is not what it says. It says equals A4. Anytime that the ribbon says equals, it says it's doing a computation. Now this isn't much of a computation. It's just spitting back whatever number is in A4. So for example, if I wanted to use the initial condition 7, 1, I would change this to a 7, and notice that in addition to A4 being changed, when I change that, A7 will also be changed because it always equals whatever A4 is. And again, I can undo that. By the way, here's a shortcut for undo, or Control Z. And you'll notice that this y value always equals whatever cell B4 is. Now, this one, the slope in Euler's method is what dy dx equals. We've been calling that capital F of xy. And up here I have my formula. Remember I solved for for y prime. Negative 2y plus x cubed e to the negative 2x. Well, notice the formula in the equals is negative 2 times b7. B7 is the y value because we're supposed to do negative 2 times y plus a7 cubed, because a7 is the x value, and we want to do x cubed times e to the negative 2 times x. And so I really mimicked what I had in cell A2 when I created this formula. And sure enough, it gave me negative 2. And now I want you to notice something. When I pressed enter, I moved down to cell C8. Do you notice the difference between the formula in cell C7 and the formula in cell C8? That's really nice. C7 has to do with the cells A7 and B7. C8 has to do with the cells A8 and B8. And see, this is the power of Excel. I'm going to right-click. If you have a touchpad, you might have to use a 2-finger tap, but I'm going to get this menu somehow. I used a mouse and did a right-click. And I'm going to copy this formula down one more section. And so I'll right-click and press paste. And when I do, well, you'll notice it shows me a 0. But the point is, look at the ribbon. The ribbon is the same formula, but now it's referring to the cells in 9. And so if we can get the correct values there, we're going to have the correct slope in C9, which will then allow me to continue. Okay, so I want to show you that, remember that this 0 was from A4 and this 0 is B4. Let's look at cell A8. What is that? It says it equals A7 plus $4. Now, A7 is 0. What's in C4? 0.1. And 0 plus 0.1, sure enough, is 0.1. Now, you might ask me, what's going on with the dollar sign? Well, the dollar sign makes it so that the number doesn't change when I copy it. Here, check this out. We're going to copy this formula down, and we're going to paste it right here in cell A9. And it gave me 0.2. That's because the formula there is A8 plus C4 again. See, if I didn't have the dollar sign, it would have changed it to C5 when I copied, because it thinks you want to move down one value. So that's kind of nice. Now let's look at the y value. This y value is a formula, and it's coming from, here I'll show you in the book. If I go back before example 1, the discussion shows you how to get the next y value, we use the previous y value plus the step size h times dy dx, which is this f. And I can do that here. I can say, to get this y value, how do we do it? Well, here, let's see how the formula B8 works. To get B8, what do? We use B7, the previous y value, plus C4, I used dollar sign again, remember that's the step size, times C7, which is the slope we computed. So what I'm going to do is I'm going to copy this formula to the next value. I'll paste it here. And what did it do? Here, let's click on the ribbon and we can see what it did. Instead of B7 and C7 there, we now have B8 and C8 there. We still have C4 because that's the step size I want to use. By the way, anytime that you're in a formula and you want to be done with it, you can either press enter or you can press escape is another nice way to do it. And so I'm ready. What I want to do now to implement Euler's method is I want to iterate this process. I'll keep computing the slope, I'll keep computing the next x and the next y. And so I can copy these formulas and I can paste them down to as many rows as I want. So if I click paste, it'll go through the next few steps. And by the way, the spreadsheet is fairly smart. If I just highlight this bottom row here, and if I move to the lower right corner of what I highlighted, you'll notice my arrow will change to a kind of plus sign. And that means if you click right now and drag, it's going to copy those formulas down and change them as appropriate. It's going to keep the step size H4 where it was, but all of these formulas work. And sure enough, this Y value, 0.13977, should correspond in the book to the Y value they got for a step size of 0.1. Let's go back to example 3 and check that out. Here's 0.1, 0.13977. Sure enough. Now you'll notice we're also supposed to do a step size of 0.05 and 0.025. So I'm going to suggest the way we do that is, let's copy everything we have so far. So I'll copy that. And let's move it over maybe 2 spaces. So I'll start here at E3 instead of A3. And I'll paste. Now when I paste, all of the formulas have been copied. Actually, you'll notice the same values showing up. By the way, I can make this a little wider by dragging it, or if I double click when I'm in mode to drag, it'll give me something about the right size. Okay. So we're getting a nice little table. And now I'm going to change this step size to 0.05, and only the things in this table will change. And again, why did that happen? Because if you look at what this says, this X value is the previous X value plus $4. It's looking at that step size for this table. So this is really nice because now I'm doing the same computations, but I'm doing the previous step size. And by the way, if I go back to the explanation here in the example, it says, in examining this table, keep in mind that the approximate value are actually the results of 20 steps of Euler's method. Right. You can't, we did 10 steps in the last example. But if I go back to the spreadsheet, if I only do 10 steps this time, I only get to 0.5. So I'll need to do another 10 steps. And so I'm going to go ahead and drag this down until I've done another 10 steps. And now I'm here at 1.1547. And let's compare to the book. 0.1547. Cool. Now we want to get this H equals 0.025 column. And so we can do that. Let's go back to the spreadsheet. Let's copy everything here. So I'll copy it, move over, 3 more places, and I'll paste it here. And better move over a little so we can see. Make these a little wider so they show up. Let's change the step size to 0.025. And I guess the next thing we need to do, of course, is copy our formulas because we're iterating 40 times now. So I need to go down another 20 rows. Let's see if that's about right. That's a little too far. I'm going to go ahead and delete everything after the value of 1. And we're in pretty good shape now. Okay. So hopefully this video helped you become more acquainted with spreadsheets if you're new to them, and also helped you understand how we can implement Euler's method for problems in this section.